Welcome back to another episode of the Supply Chaney podcast. I'm your host, Nathan Chaney, and we're doing something a little bit different today, where typically I have just one guest. Today, I'm going to take on two at the same time. And I think it's going to be extra special because this is a special edition that's been organized by MHI. And both of these individuals here today are with companies that are part of their Conveyor and Sortation Systems industry group. And we want to talk a little bit about what goes on within the four walls of warehouses, but more specifically, highly automated warehouses that have a lot of conveyors and sortation systems going on. And both of their companies are innovative and driving things forward when it comes to cabinet-free automation. So in addition to our normal, let's learn about the people in the supply chain industry, we're going to dig into cabinet-free automation toward the end of this episode. But let's get things started here. First, Nathan, I'll give you the honors here of doing first introductions here. The name is so easy for me to remember, so I give you the first shot here.
Sounds good. Yeah, I'm Nathan Hibbs. I'm with Beckhoff Automation, and I'm the business development manager for material handling and intralogistics. I live in the Atlanta area and went to Georgia Tech.
Okay, excellent. Welcome and thanks for joining in today. Zach, how about yourself?
Hi, I'm Zach Bauer. I'm the sales development program manager for Murrelektronik. That just means I'm responsible for training and supporting our sales team as we work with our partners throughout the country.
Excellent. Well, again, welcome to both of you. I'm interested to learn more about the nitty gritty of what you all do. But first, I'd like to kind of unpack and just learn, a little bit about your personal stories and your careers that got us up to this point today. So, Nathan, can you kind of talk a little bit about, did you grow up in the Atlanta area? Like kind of what's your background?
Yeah, actually, I didn't grow up in Atlanta. I'm from Minnesota, land of the cold, and I decided I hated the cold, and I was always interested in engineering ever since I was a little kid. It might sound kind of boring, but anytime since I was like 5, anybody would ask me what I want to do, I would always say I want to be an engineer because my dad worked in a related industry, and he would always talk about the engineers at work, and I apparently thought that was cool. So I ended up looking at a bunch of colleges and visited Georgia Tech, and is a very strong engineering school. And it was warm, so it was a side benefit of no snow, which I enjoyed. And then, I ended up kind of planting my roots here eventually.
I see. What was one of your sort of earliest light bulb moments that you're like, I want to be like, was there one concrete like science experiment or something that you recall that was like this solidified my reason for being?
Maybe not like that, but I would always watch. I was like obsessed with the TV show How It's Made. So
Okay.
I'd always watch, all the manufacturing and, the cool automation and how everything around us is made. So I guess that kind of, this job is that every day.
Yeah, guilty. I've watched a few episodes myself, so that's excellent. How about you, Zach? What's your kind of origin story like?
Yeah, so I grew up in Western Pennsylvania, about an hour west of State College, so really the kind of middle of nowhere. Went to a Du Bois Central Catholic for 12 years of education and was really drawn to math and science and those sorts of things. So I graduated and went to Allegheny College to pursue a degree in physics, really with the motivation of being a professor one day
Okay.
and doing research and teaching new people new things. And pretty quickly realized that the hours and the grading of papers and all of those things wasn't exactly for me. So after graduating, I got a job as a quality engineer at an electronics manufacturer. Did that for about a year and a half, and then moved to the Philadelphia area, where I still live with my wife and dog and cat. And worked for IFM for about 5 years, and then some time with LAP, and now have been with Murr for just going on 4 years now.
Okay. All right. Awesome. I've been attending a lot of trade shows, a lot of pro mats and whatnot type of shows, and I've seen both of y'all's companies there, and so this is a real treat for me to be able to take sort of those conversations and bring them out, get a microphone and camera on, and take the next step. Nathan, we didn't quite talk through your sort of career progression. Like, what are some of the stops that you've made on your path?
Yeah. So when I graduated college, I got a job with B&R Automation. So competitor, and that kind of introduced me into the industry. And I was there for about 10 years, and then I've been with I moved right to Beckhoff Automation for about 4 years now.
Well, so what's interesting to me is I also thought that I wanted to be an engineer one day. And, I had some influences from family members that were engineers. And what I realized is that the math was probably a little harder than what I think I could handle. So I went the business school route instead. I took a detour at some point in time and found myself in logistics. But you all have arrived here as well. And so you get to kind of combine both an engineering perspective and a little bit of supply chain and logistics, but also you're both kind of wear business development hats. So I'm kind of curious, maybe one of you, if you could chime in on how you approach, a business development type of conversation, but with an engineering and a technical focus.
It doesn't matter to me. So from really Murrelektronik standpoint, we really want to meet customers where they're at and really understand the way that they're doing things right now. I think over the course of the last, especially 5 years of supply chain difficulties, a lot of companies have really pulled off a lot of supply chain miracles themselves to deliver more efficient supply chains to their end customers. And that's the chip issues in early 2023 and just continued supply chain disruptions and things like that. So really, we want to understand what is it that they're doing now and where are they having difficulties? Where are they wasting time? Where are they leaving money on the table? And the piece that I always like to touch on is the components that we sell aren't the cost driver for these systems. Fundamentally, Murrelektronik makes I/O modules, connectivity, and other things that really exist between what I call the application layer, which is all of your drives, your motors, your sensors, and your control level, which is your PLCs and your plant infrastructure. An M12 cable might be $25, but if we can help you apply that in a more efficient way, help you build your machine faster and reduce the labor associated with it, that's where we really add value to these companies at an engineering.
I see. It's truly kind of the science and engineering behind the systems, and systems all have a cost associated with them. And Nathan, what's your take on that topic?
Yeah, maybe a little bit different because we kind of have take a look at the whole system, and we tend to focus on the what's wrong or what's the problem, the pain point of the customer first, because we don't expect them to know how they could do it with our system, and we do things a lot differently. With our architecture, you can do a lot more with a lot less, but we don't expect the customer to know that. So we really want to figure out what they're trying to do, what their pain points are, and then we come up with the ideal solution for them and introduce them to new technologies like cabinet-free automation.
I see. I'm curious, before we kind of dig into more of the nitty-gritty details, if you can comment a little bit on your relationship and how you all engage with the industry group and with MHI in general. Like, what kind of purpose does it serve, and how do you leverage it to make your businesses better and be able to provide better solutions for your customers?
Yeah, so I'm pretty involved with the industry groups. We were just last week, we're at the MHI annual conference, which was a great time. And I like to use the groups as, first, networking, meeting everybody else in the industry, figuring out, talking, hearing about their, issues and how they're going about things. And there's a lot more similarities than you would assume. And then also hearing from, what the market is saying, just making sure that we're covering all the demands of end users. And sometimes we'll hear the perspective of the users. So that's very interesting too.
I see. I'm bummed that I wasn't able to get out there to Tucson last week, but looking forward to seeing more pictures and hearing more stories from the conference. Zach, how about from your perspective? What's your engagement like with MHI in the industry group?
So most of my experience with MHI has been centered around some of the trade shows recently, Modex and things like that. Working at those events and getting to meet different MHI people and things like that has been great from my perspective. From a from a broader Murrelektronik perspective, we're pretty involved in a lot of the different groups, CSS among others. And for us, it's really been an opportunity to connect with fellow companies that are looking to improve processes and understand the challenges that they face. And really that helps us guide the messaging that we bring into the market because we can talk a little bit more closely to the issues that we're hearing from the different people in those groups and things like that. So definitely very, very similar to Nathan's approach. It's just a great opportunity to connect with people that are operating at different levels within the supply chain industry. And I think that those diverse perspectives help us align incentives for machine builders, integrators, and ultimately the end users that are running these facilities.
I see. I see. Thanks for that. I'm curious if before we dive into where the state of the art is today, if one of you could kind of give a little bit of a history lesson on conveyor and sortation systems and kind of like where the state of the art was, 10 and 20 years ago. If one of you all have kind of this passion for history and storytelling, I would love to hear and catch us up to where we are today.
I could
All
I
right.
could take that. Yeah. So conveyor and sortation systems, they're very large. So, physically large. There could be miles of conveyor in these facilities, and sortation, sorters can be, hundreds of feet long. So it requires lots of I/O, lots of motion control, and very distributed. So it has to be, they're very spread out. There's lots of, I/O nodes, lots of things to talk to. So traditionally, because of some limitations with, industrial field buses and PLCs, a lot of times they would have to hardwire things back to distributed control panels, which, you have big bundles of hardwired cable all down your sorters or all down your conveyors to kind of eliminate or limit the number of industrial Ethernet nodes in the system. So now with newer technology, like EtherCAT, it's a big enabler in these systems. You can have tens of thousands of nodes in one network, and you can actually individually address every single, let's say, MDR controller, or put an I/O block, all along your sorter, so you don't have to run long hardwired runs back to, distributed control panels or very large control panels. So it makes OEMs and end users much more flexible, and it makes things easier to diagnose as well.
I see. I see. And did I hear the word IO or was that IoT or could you elaborate on that particular acronym?
Yeah, that was I/O, output. So digital inputs, digital outputs, analog, controlling, reading signals in and controlling actuators.
I see. I see. Any comments on your side, Zach, of kind of like that history of where we've been?
Yeah, absolutely. So I think supply chain history is really interesting because it's kind of evolved in parallel to industrial automation. And I think over the last 15 to 20 years, especially, you're seeing more of those technologies from automotive and other automation that are moving into supply chain and logistics with things like robotics and things like that. Specifically, I think within the conveyor and sortation space, um, the the market is at a place where you have a lot of legacy systems that are running on AC power and AC motors that might be three phase, they might be single phase. There's a lot of different drive configurations, legacy PLCs, and things like that that are out there. And as the market continued to evolve, you got field bus and you got MDR cards that run on 24 volts and a lot more of this complexity. So I think for a lot of those big end user or end practitioners of sortation and people that maintain this, um, there's a lot of questions of what does this next generation look like, and how do we make sure that it meets our evolving business needs for changing flexibility and more SKUs and more scan points and all these different things that really, how do we use what we have, but also start to leverage some of those, as you said earlier, Nathan, IoT capabilities and things like that. How do we target sources of downtime and things like that?
From one thing that I've seen from my perspective is a proliferation of robotics and automation and modular systems and ASRSs and all these sort of things that are not necessarily conveyors and sortation systems. Maybe they're sortation systems in a way. But from y'all's perspective, this is where you're experts at. Is there some kind of effect on just like the general market for miles of conveyors and all this sort of stuff by kind of the growth of this modular goods to person robotics? I call them turtles, like the Kiva type systems. Can you kind of comment on what you're seeing, at a high level, Zach?
I think that in general, those types of systems bring a lot of flexibility and density and different benefits. But those systems are also fed by conveyor systems.
Okay.
If you're putting in an ASRS system, it's very likely not right next to your dock door, and somebody's just putting that package into the tote. It's getting conveyed away from that goods to person station and going to another location to maybe be packaged and processed out the door. So I think that these solutions, like ASRSs and all of these robotic solutions, don't eliminate the need for conveyor, but they change the application and they allow it to be a piece of the system rather than the whole system.
I see. Any comments on that, Nathan?
Yeah, I would say there are actually some customers or companies that are using AMRs for sortation, so that is kind of like a new thing as well. But yeah, I agree. All these new robotic systems are fed by traditional conveyance, and I don't see that going away. I would add that there are some also new technologies like intelligent transport systems where you can have like independent movers that are electromagnetically propulsed to move individual products if you need. And it's not going to replace an entire conveyor, but where you need speed or precision or some sort of special movement where there's a value add, then these new intelligent transport systems are for sure taking.
I see. I see. I feel like everything that I'm hearing, and I'll ask you to kind of define what cabinet free means, but it sounds to me like everything that I've done looking into it is that it improves, cycle time and installation time and all that sort of, to me, lends itself to being more flexible and able to update and change with changes in needs in warehouses and distribution centers. But maybe, Zach, could you define what cabinet free means?
Yeah. So, I think cabinet free is an aspirational thing for me. We're not at a cabinet free future yet. There's going to continue to be your companies that manufacture cabinets, and we're going to keep putting things like power supplies and Ethernet switches and PLCs in them. But I think really what cabinet free is about, it's about simplifying those cabinets, removing as many things out of those cabinets as we can, and then developing system architectures that allow plug and play connectivity for things like I/O, motors, on-machine power supplies, safety, because I think, as we talked about earlier, the needs of a sortation facility or the needs of a distribution facility today are not the way that they're going to be, or not what they're going to be tomorrow. So we need to be working to develop cabinet-free solutions that don't have hardware that is set in place, but rather it's a small function in a modular piece like Legos. So we often talk about building a factory with Legos, that you just plug and play and put pieces together and they work. And that solves a lot of problems for end users around maintenance challenges and downtime, because when something fails and you don't need to open a control cabinet, you just need to unscrew a cable on both ends and reconnect it. That adds a lot of value, that reduces the downtime, and you have much more efficient operations.
I see. Nathan, what kind of definition do you have for cabin free? I really liked Zach's, there being kind of an aspirational concept. What's your look there on your side?
Yeah, I actually would say that we are there just now. It's not. It used to be aspirational for sure, and it's been going. That movement has been going for a while, trying to shrink machines and distribute things as much as possible. But we have just released, fully released the MX system, which is a full cabinetless or cabinet-free automation. So you really can have machines without any cabinet. So one mains power in feed. It has the disconnect, it's modules for drives and power supplies and IO, safety, etc. And then those are modular. You can distribute these backplanes, throughout a machine, and yeah, connect different modules of the machine to with one cable. Power, distribution, and communication in one cable.
I see. I'm curious then, thinking about the growth of just the proliferation of warehouses and distribution centers and manufacturing facilities. I'm curious, are these cabinet-free type of installations something that is a retrofit option for existing systems, or is it mostly for new builds, greenfield type projects? What's the ideal application for the use?
Yeah, from my point of view, it could be either.
Okay.
Because I think the benefit is you're not having to, if you want to do brownfield installation, you're not having to find a whole, space for a giant floor standing cabinet, to wire everything back. You don't have to worry about a bunch of power drops along the machine. You can just mount this base plate to the side of the machine, the frame. You don't have to find a spot for a cabinet, and it can accompany the actual frame of the machine. So it makes reconfiguring and installing in brownfield easier. Also because it saves space. So not only do you just not have to find a spot for these cabinets, the machine's footprint can actually shrink, so you can get more done with less space, which everybody likes.
Interesting. But if you are building a brand new building today, is this kind of like what your systems engineers are going to try to build in from day one? This is going to be, in service for many, many years. So you kind of want the state of the art everything when you build a new facility. What's your thoughts on that, Zach, when we're looking at greenfield projects?
Yeah, I think that there's a lot of questions about how greenfield projects kind of also fit in with other facilities that you may have and expertise that already exists within your company.
Good point.
So, a solution like the MX is very similar to MERS Vario X, which is, MERS approach on the same sort of thing, on machine PLC with integrated power supplies and all of those things. I can tell you we can't make enough of them to replace all of the Allen Bradley and Schneider PLCs in the world, and we don't intend to. Really, MERS approach is much more broad and essentially working in a way that's agnostic to those higher level systems. So, if you guys want to use an MX, use an MX, and we'd be happy to support the connectivity. We work with companies that use all sorts of different automation architectures, both at that control level, the PLC level, or at the machine level with the application level. We really, part of our core DNA is that we are agnostic to a lot of these platforms. So when we would approach a greenfield facility, it's really about what is your team doing now and where does our product fit into what you guys are already trying to do. So that's generally the MER approach.
I appreciated your comment about, where is the rest of your resources and capabilities at all your other facilities, and taking that into account. And, that seems like a smart strategic choice there. So Nathan, in the pre-show, we were talking a little bit about what the ROI and cost savings looks like when you're considering a cabinet-free type of approach versus traditional. Is the savings in, the installation, the wiring, the footprint, energy use, maintenance, all those sort of things? Can you kind of break down where and what those numbers are?
Yeah, so of course it's going to change based on, for every application, but we have taken a look at some actual machines of our customers in real life and seen what kind of savings and kind of quantify them. So just a few of them offhand that you might not think of. There's up to 75% fewer pages in your electrical schematics because there are 90% fewer components. So because it's just made up of a bunch of larger modules that you plug into a base plate, you just eliminate a lot of these components. So you have less pages to turn through when you're trying to find something in your schematics. Up to 90% space savings. So not just footprint, but volume as well. So a lot of times cabinets can be quite deep and hard to fit in your machine. You can fit these base plates, or you can fit the distributed controls basically anywhere tucked underneath the frame of the machine. So it really, really saves footprint and space. Up to 95% reduction in setup and testing. So we had a customer, it normally takes them 28 hours to kind of assemble and wire up and test a panel, like when they're trying to build up a machine. And they were able to do that in an hour with an MX, a fully distributed cabinetless system. And then you mentioned energy efficiency. So typically, a lot of times, the cabinets will need air conditioning, which is energy and it's cost, where all these distributed components are just passively cooled. You mount them to the frame, they eliminate all their heat, through the frame of the machine or through convection.
I see. Zach, could you comment on any of that? And kind of given that you are Murrelektronik, could you kind of speak a little bit to kind of the energy savings that you all see with your designs?
Yeah, absolutely. So, we, as I kind of said, are the infrastructure or the middle part of the machine. So that includes things like power supplies, Ethernet switches, all of those sorts of things, which we're able to take out of the control cabinet and put on the machine, which ultimately will result in shorter cable runs, double-ended cables that are easy to install, LEDs on modules that give you troubleshooting information, and all of these sorts of things. Ultimately, those sorts of things we like to track to the end benefit to the customer, in which case often the OEM talking about the number of control cabinets that they build, reducing that to as small as possible. The number of things like terminal blocks and wire labels that are often used inside of control cabinets. These are things that are traditionally associated with machine building, but aren't necessary with the automation products that are available in the market from Murrelektronik and others. So when we take that approach, we look at places where labor is being spent either inefficiently, creating 75% of the drawings that are unnecessary, or the physical time of somebody putting those wires into the terminal strips inside of the control cabinet. Ultimately, that reduces the troubleshooting time because you have LEDs that are out on the machine to tell you where the problem sensors are. It can also lead to a vendor reduction. All of those middle inside pieces of various cables and bits and bops of power generation and circuit protection, Murrelektronik is experts at all of that. And so we can help streamline that entire segment of your machine building across all the different parts of your operation.
I see. Okay. Let's kind of turn the conversation here as we wrap up toward a kind of a future focused look at all of this. Nathan, could you kind of comment on where you see the technology going? Where are things heading here in the next 5 years or so?
So specifically around, cabinet-free automation, I personally do see that a lot of, not all, but a lot of machines will have more and more, cabinet-free. Maybe they don't start out with fully cabinet-free, but it's as simple as distributing your I/O blocks, out onto your machine, but all the way down to, a full cabinetless automation solution. So I see that like in 10 years, I would say a lot of, or the most of machines will adopt that because the savings are so significant in labor and all the other things we mentioned. Like you don't have to have an electrician to plug in a connectorized cable where you might have to open a cabinet, you got to suit up for arc flash, you got to be an electrician, you got to, land the wires. So it's removing a lot of the training, some of the training necessary, making it easier to maintain and work on this equipment.
I see.
Also,
I
one thing
see.
we didn't mention was being able to have one standard machine, regardless where in the world you're sending it. So if you're making a machine with a bunch of components that all have, CE, UL, CSA, etc., you don't have to, have a completely different panel design, completely different drawings if you're sending it to Europe, or if you're sending it to Asia, or if you're sending it, if you have it in the US. So that is also kind of a benefit that people don't really realize.
Makes sense. And it kind of speaks to Zach's concept of having a solution that can work across all facilities wherever you may be implementing in the world. Zach, do you care to comment on kind of where you see the state of the art going over the next 5 years or so?
Yeah. So I think that one of the big trends that I think we'll continue to see over the next 5 years is IO-Link. The technology as a whole has really opened up a lot of possibilities of what's possible to get from your sensors in terms of data. And ultimately, I think that we're not really there yet in a good way of understanding how to leverage that data to improve processes. But I think that we're getting there with a lot of the new AI tools and things like that are coming in development. Along with that, you're seeing more Ethernet networks. You're seeing additional data collection, and I expect to see that continue with people looking to really gather more data to help inform business decisions around when maintenance happens or solving downtime issues before they really manifest. And then the other one thing that I'll mention kind of happening in concert is pneumatics is really, I think, struggling just from a cost perspective of generating compressed air. It's a really massive cost. It's a really difficult thing for a lot of these facilities to maintain compressor rooms and things like that. So I think that the rise of 48-volt power and electric actuators will continue to push pneumatics out. And you'll see more and more fully electric systems with regenerative braking and all of those things that ultimately support those energy usage goals.
Oh, I like the call out. That's I've been in a number of facilities and run some facilities with conveyors, and you're right. The pneumatic situations, I can see that kind of fading into the background a little bit now with the introduction of all the electronic interfaces and motors. Maybe one last question for each of you. We've been talking a lot about all the good benefits and features and kind of it just kind of seems like a no-brainer. So I'm kind of curious from each of your perspectives, like what is one misconception or barrier that's kind of slowing adoption? What resistance or friction are you seeing? And I'll just let each of you kind of pick one. Nathan, you want to take a shot?
Yeah, I'd say the biggest one that we always talk about every time we show a customer, they're like, "This is great," but it looks expensive. And to their point, it is a little more expensive than traditional cabinet-based automation. However, it's not that much more expensive. And when you take a look at the total cost of ownership that we've been talking about this whole time, it is a no-brainer. Like you can quantify these. Even if you're ignoring some of the hard to quantify things like the ongoing maintenance costs, but even just the labor reduction in building it up and commissioning a system is basically pays for itself up front. So yes, people think it's expensive. It is a little more expensive. So you have to kind of, you can't just compare apples to apples of, hey, there's my bill of material for the traditional way versus the fully cabinet.
Okay. All right. Nice call out. Zach, what about on your side?
Yeah, I think for me, the biggest obstacle that we see to moving towards more cabinet-free decentral automation is we've always done it this way. And we hear that from practitioners with their specifications. We hear that from machine builders, and we hear that from integrators. The move away from in-cabinet I/O to decentralized I/O seems like a scary jump. But this isn't a new technology. This is something that the industry has been moving to for over 2 decades at this point. And Murrelektronik's been there that entire time with various decentralized I/O solutions. Right now, we're seeing that same revolution happen with Ethernet and happen with power distribution and all of these other things that are traditional cabinet things. They're migrating to the machine. So my advice is keep an open mind and look at total cost of ownership.
I like it. I think that kind of just sums up a lot of what we've talked about here today. And I appreciate both of you coming on and sharing your expertise in this area. Again, and also just shout out to MHI for kind of introducing all of us together and bringing and making this conversation here possible. Any last words from your side, Nathan?
Nope. I think, if you guys are interested, if anybody's interested, reach out.
All right. Last words on your side, Zach?
I just wanted to say thank you to you for hosting us today, and to MHI and the CSS group for all the great work they do for this awesome industry.
Excellent. All right. I'll see y'all around.
Thanks.
Thanks.